Hello everybody, welcome to a chat from the engineering desk. Today we're going to be talking about full bridge rectifiers, and I've set up a nice little demonstration for you guys here. On our breadboard we're going to be using an oscilloscope and a signal generator. Now I'm going to show you exactly how a bridge rectifier works. You get to see it in action, it's nice. So on the breadboard, here's a little circuit that I built. The signal generator is going to inject AC over here into our bridge. There are 4 diodes there. 2 for the negative side, so your cathodes are connected to the AC, and then your 2 for the positive side, so your anodes are connected to the AC. Over here in series with all 4 diodes, I've got LEDs which I'm going to show when the diode is in conduction. That's why they're there. The DC goes out to our load, so here we have positive out, to our load. And then over here the negative comes out, goes to our capacitor, the reservoir capacitor, goes through a current limiting resistor and goes to the cathode of our LED. So when this side of the mains is at negative, that side of the mains is positive, current flows in this direction. So we're going to see that LED on and that LED on. When the cycle goes through 180 degrees, you now the half cycle, current flow is going to be in that direction. You're going to see that LED on and that LED on. You'll also see that LED turn on while current is flowing through these diodes. So I'm going to take this away because I think we're done with that. Bring in the oscilloscope. And keeping it all intact. So what I'm going to do next, turning up the frequency a little bit, is I'm going to select square wave on the AC side. Watch what happens to the green LED. Now it's going to take a few seconds for the scope to roll over and start displaying that. So there we have it. This LED is staying on all the time now because we have square pulses that are coming in on the AC side. And you also notice on the LEDs we're not getting that smooth changeover like we did with the sine wave. Going back to sine wave, now you can see the transition again. Slow that down a little bit. Go to a triangular wave. See how the appearance of the LEDs flashing over here has changed. It's a lot more linear now, the increase in brightness, because what is happening, you've got a triangular wave coming into your bridge. And going back to the sine wave, you can see it's got a sinusoidal increase in brightness. It's not linear. I'm waffling on now. There's our bridge. 2 pairs of diodes conducted any given time, converting our AC into DC. And with the help of the LEDs we can see that actually happening. That's a full bridge rectifier. I do have a capacitor in here. So what one would see over here is that no storage of DC is now taking place. You can see in between the pulses going back to 0 volts on the scope. Putting it back, and you'll see that the pulses no longer come all the way down to 0 volts again. So that's how the reservoir capacitor in a rectifier works. That's your DC capacitor over there. I've just got a small capacitor in here, which is why you're not seeing a straight line at the bottom. But that's fine, we're talking about rectifiers. So I hope you guys enjoyed this presentation. It's different and it's interesting. Hope you learned something from it. And for the rest, have a wonderful day further. Thanks for being here, and I'll see you in the next video. Thank you. Cheers. Now for some bonus content, because you guys are probably wondering what was wrong with my earlier demonstration. See, now we've got a nice symmetrical DC waveform. Let's try that again. Helicopters. And now for some bonus content. You guys are probably wondering what was wrong with my original And now for some bonus content. You guys are probably wondering what was wrong with my original setup and why this over here was not symmetrical, and why that over there didn't look right, and why the 10 volts out my signal generator was lopsided. I had both the 0 volts of my scope probes connected to different places on my rectifier. It doesn't work very well. So now, slowing it nicely down, we would even illumination on the pairs of LEDs. That's the way it's supposed to look. So those of you who are wondering what I was up to, yes, there was a problem. Thanks for joining me for the bonus content and blooper reel. See you next time. Cheers.